This problem is using a chart to estimate a value for the second derivative at a particular x coordinate. So what's wonderful about mathematics is when you're given a table, that's all that you can assume. So this is my data, these 6 points. All I can do is use this data to make my estimate of v double prime of 3 as accurate as possible. Now, most people think, oh, it's not very accurate. Well, you know, this is all I got. And I can't extrapolate or interpolate anything from it because I'm just using the data. I'm not coming up with a function or anything like that using regression. I'm just going to use difference quotients. So I do know that v double prime of 3 can be approximated by taking v prime of 4 minus v prime of 2 dividing by 4 minus 2. So that's change in output over change in input. That's just the equation of a slope, one derivative less than what I'm looking for. Now notice this chart is giving me v of t, not v prime of t. So I actually have to estimate v prime of 4 and v prime of 2 separately, then put them back in. So v prime of 4, again using the difference quotient, is going to be v of 5 minus v of 3 divided by 5 minus 3. Now, many of you might be asking, where's v of 4 in here? Where is it? Well, v of 4 is halfway between 5 and 3. So what I'm using is something called the central difference quotient. In other words, the number I'm looking for is in the center of the 2 points that I'm using for the difference quotient. That makes that, it turns out that it's a little bit more accurate than any of the other methods that we use. So again, this is an approximate. I should be proper. V of 5 is equal to 88. V of 3 is 68. 5 minus 3 is 2. 88 minus 68 is 20. 20 divided by 2 is 10. So I need to remember v prime of 4 is 10. So if I keep going up here, I have 10 minus, I'm going to come up with v prime of 2 in a minute. 4 minus 2 is 2. So now let's go back down over here. I want to do v prime of 2 now. So let's move the paper down a little bit so we can see the work. V prime of 2 is going to be v prime, so just think, 2 numbers just on both sides of 2 that are in the chart. So that's v of 3 minus v of 1, because 3 minus 1, 2 is right smack in the middle. All of this is on the chart. 3 minus 1. Now v of 3 we saw earlier was 68. V of 1 is 30. 3 minus 1 is 2. 68 minus 30 is 38, I'm thinking. 38 divided by 2 is 19. So that means v prime of 2 is about 19. So I'm going to take that number and I'm going to plug it in up here and finish the math. 10 minus 19 is minus 9. Minus 9 divided by 2. Well, that's minus 4.5, but I mean, it's better to leave it in exact form in my opinion. If you're doing a word problem, then minus 4.5 makes sense. I guess this is a word problem. What would be the units of measure on this thing? Well, v of t is feet per second. V prime of t would be feet per second squared. So v double prime would be feet per second cubed. Feet per second cubed. I had a student say, does that make any sense? And I said, well, it may not, but it's the actual mathematical unit of measure based on the setup that I have here. And it may not be anything real practical, but nevertheless, that's what it is.